We are starting 4-3 today, which is logs. So we're just going to start by defining what a logarithm is. So we'll mostly be doing A and C today, and then tomorrow I'll pass it the calculators to do a little bit of objective B, and we'll do D and E tomorrow as well. Okay, so this is what a log expression looks like. You would say in words, log base b of x. Okay, so that's how I would say that, log base b of x. What's important to note is that this equals this. Those are the same thing. This is just log form. This is exponential form. We'll need to know how to write things in both forms. That's what we want to start off doing. If I'm going to switch from log form to exponential form, so things to note is that the base of your log is the same base as the in exponential form. Okay, the bases are the same. The answer to a log is the exponent in exponential form. So we're going to write these in exponential form. We're not solving or evaluating. The answer's already there. All we're doing is rewriting. So it's log base 3. So the base is the same. The answer to a log is the exponent. And then that leaves me with equals 9. 3 squared equals 9. Does that make sense? Does 3 squared equal 9? Yeah. Okay, so when I rewrite it, check to make sure, okay, that is true. Okay, let's look at the next one. Okay, what's the base of my log? 81. The answer is 1/2, so that's the exponent. Remember, if your exponent has a fraction, the denominator is the root. So square root of 81 is 9. Okay, and one more, go ahead and do this one. Sydney, what do you have?
I have e to the first power.
E to the first power equals e. Yep, good. Questions about that? Okay, we're going to go in reverse. I'll come back to this top here in just a minute. And let's write in logarithmic form. So now I'm going to take exponent form and I want to write it in log form. The base is 8, so that means it's log base 8. Okay. The answer to a log was the exponent, so I know it equals 0, 1 goes here. Log base 8 of 1 equals 0. Okay, do the next one. Okay, Mason, what do you have?
We have log base 4.
Log base 4, okay.
8 equals 3 over 2.
8 equals 3 over 2. Yes. That is correct. Okay, so you have to practice that a little bit so you get that memorized. You will need to know how to do that when we're solving and also graphing. Just rewriting an exponential form. That's pretty important when you're doing logs. Okay? All right, you have these two log buttons that are on your calculator. And they're on scientific calculators, they're on the iPhone calculator. So they're pretty common to be on the calculator. And we'll talk about evaluating tomorrow because I know not everybody has a calculator with them right now, so I'll pass them out tomorrow. But just so we recognize, so the common log is log base 10 of x. So it's written just log x. So if the base is not seen, we assume that it's base 10. You have a log x button, a log button on your calculator. Natural log is also a log button on your calculator. And that is log base e. So log base e of x, and it's written just like this, ln, so natural log of x. There is an ln button on your calculator as well, and that's log base e. So when you have to do any evaluating, if it's log base 10 or log base e, natural log, you can evaluate with the calculator. Now, if you're trying to do log base 8 of something, some of the newer graphing calculators have a base b button where you can plug in any base. But the older ones, scientific ones, those don't. So we will rewrite them in exponential form to solve. Also, on your quiz, we have problems you have to solve without a calculator. Okay, so these types of things could show up on the no calculator part of your quiz. So we're evaluating log base 9 of 9. All right, there's not an equal sign there. So just to help me write it in exponential form, I'm going to put an equals x. Okay, now we can rewrite it in exponential form. My base is 9, the answer is the exponent, and then equals 9. So 9 to what power gives me 9? 1. So x equals 1. So log base 9 of 9 is 1. Let's do the same thing with 42. Give you a minute to do this one. Make a note here that we write this in exponential form. Okay, Jacob, if I write this in exponential form, what would that look like?
12.
Good. 12 to the x equals 144. So what's my answer, Jacob? X equals 2. Good. So log base 12 of 144 equals 2. So these are pretty easy so far. They do get a little bit more complicated. And even this one that we're going to do is not quite too difficult. Lauren, what does this look like in exponential form? Good. 9 to the x equals 1 over 81. So let's think about what we did yesterday when we were solving these exponential equations. We wanted the same base. So the base on the left is 9, the base on the right is 1 over 81, but the 1 over just means negative. So I'm really looking at 9 and 81. So which one's smaller between 9 and 81? 9. So I want to write them both as base 9. Okay. I need these to be the same value. So how can I write 9 as one? What exponent could I put here? So it's negative because it's 1 over, and 9 to what power gives me 81? Good. So negative 2. So therefore, x is negative 2. So log base 9 of 1 over 81 equals negative 2. Yes?
You want us to include it like on the test stuff? You want us to include the stuff where we move both bases on it and go straight from the 9 to the x?
If you have this, you mean here? Yeah, you could, if you could have this, you can go right to here if you know. But when it's like the ones we did yesterday had like x minus 3 and you had to solve a little equation. It's not quite as simple as that. But yeah, if you can do that, you can go ahead and write x equals negative 2. Okay? All right. So now we're going to talk about graphing some logs. So some of you might need more graph paper. If you do, feel free to take a piece. If you don't, you can pass it on. All Okay, so if we're graphing log functions, so if we're graphing f of x equals log base a of x, first of all, you can't take the log of a negative or 0, so that's why it says greater than 0. So all your values of x have to be greater than 0. Your base is also greater than 0 and not equal to 1. So just in general, that's some info about log functions. Okay. So when I graph log functions, I want to write them in exponential form because it's easier to make a table if it's in exponential form. So I'm going to write y. So if I write this in exponential form, my base is 2. My answer is y. So 2 to the y equals x. Okay. Because my exponent is y, so with exponential functions, the exponent's x, you plug in numbers for x. My exponent's y, so to evaluate this, it is going to be easier if you pick numbers to plug in for y. You're still going to graph them as a normal xy ordered pair, but just evaluating, making your table, it's easier to plug in for y. Exponents and logs are inverses of each other. So their ordered pairs are switched. That's why we can plug in for y. So go ahead and go to 3. So I'm plugging in for y, so 2 to the negative second power is 1/4. 2 to the negative first power is 1/2. 2 to the 0 is 1. 2 to the first is 2. 2 squared is 4. And 2 cubed is 8. Okay, when I go to graph these, I'm still graphing them as normal ordered pairs. So x comma y. I'm not switching. If I switch the ordered pairs, then I get an exponential function and not a log function. So 1/4 negative 2. 1/2 negative 1. 1 0. 1 4 2 and 8 3. This is a log function. It is the inverse of an exponential. So instead of coming down like this, I'm going the opposite, like this. Instead of having a horizontal asymptote, I now have a vertical asymptote. Okay, vertical lines are x equals, so the equation is x equals 0 of my asymptote. Okay, this is the graph of log base 2 of x. Okay, let's look at the domain and range. Do you have a minimum x value? Yeah, I have an asymptote here, so I have a minimum. It's 0, but I don't touch it, so parentheses. What about a minimum y value? Nope. Do you have a maximum y value? No. Okay. Log functions are inverses of exponential functions. Inverse functions, your domain and range switch. So with exponential functions, your domain was all real numbers. Well, now that's the range. Because you can plug in anything for y. The range was based on the horizontal asymptote, but now for log functions, it's based on your vertical asymptote, and that's your domain. Okay? Okay. So we're going to look at another one. So we're going to look at another one with some transformations. Okay. Like exponents, the parent function is just the base with x. So for this function, f of x, the parent function is y equals log base 2 of x. So without the minus 3 and the plus 1, it's just the base with x. Okay? Remember how to graph log functions, rewrite them in exponential form, and plug in for y. So I'm going to copy down the same table we just used. So I plugged in numbers for y. Okay, I'm going to graph the points. I'm not going to connect them, but I'm going to graph the points. So for the parent function, I have a vertical asymptote at x equals 0. And I have these points. Okay. So once I have those, let me go back to the what I just started with. When you have a minus 3 inside with x, that means you're going to shift right 3. So just because you're thinking you had to do opposites on the table, that doesn't mean you change anything else to be opposite. You cannot write this in exponential form either. You can only write the parent function in exponential form. Okay, so back here, you want the transformations, and then that plus 1 means you shift up 1. Okay. If I shift my asymptote right 3, will it change? Yes. What about if I shift it up 1? No. So when it's log function, when it's a vertical line, it will change if you move right or left. Remember, exponential functions, the asymptote changed if you moved up or down. Okay, so I have this new asymptote. That is at x equals 3. I'm going to take all my points and shift them right 3 and up 1. positive infinity. What would my domain be now? Good. 3 to infinity. Okay, good. Okay, this is essential to graphing this. You have to know how to find the parent function and how to write that exponential form. There is a question like this on your quiz. And then once you write it in exponential form, you have to understand you're plugging in for y, not x.